This video is on Unit 4, Chapter 8, Intro to Polynomial Functions, Lesson number 2, Dividing Polynomials. In the first set of examples here, under dividing by a binomial, we are going to use factoring to divide the polynomials. In question number 1, we've got w squared minus 7w plus 10 divided by w minus 5. So we're going to factor that numerator. We need a number that multiplies to give us 10, that adds to give us negative 7, which would be a negative 5 times a negative 2, because negative 5 plus negative 2 is negative 7. So the numerator is going to factor into w minus 5 times w minus 2, and that's being divided by the w minus 5. Now, when we go to reduce this, w minus 5 is a binomial. We can only reduce fractions that have binomials as long as the binomials match exactly. So the w minus 5 in the top can cancel with the w minus 5 in the bottom, leaving me with w minus 2 for my answer. On question number 2, I've got 4h squared minus 7h minus 2 divided by h minus 2. So we got to factor the 4h squared minus 7h minus 2. So I need two numbers that multiply to give me negative 8, that add to give me negative 7, which would be a negative 8 and a positive 1. So I'm going to see if I can't scrunch all this. That would be an h minus the 2 group. Bring out the 4h. H minus 2. Now for this other one, the common factor here is just going to be a 1. And then notice you've got the h minus 2 times the 4h plus 1. And all of that's being divided by the h minus 2. And then in this case, the h minus 2s are going to cancel, leaving us with 4h plus 1. So that's what dividing by a binomial would look like. Now, when we get down to this next section, it says, what if factoring is not possible? What if factoring is not possible? So there's two different methods that we're going to look at. The first one is long division. The second one is synthetic. With long division, your x squared plus 3x minus 43 is going to go inside your division symbol. And that's being divided by the x plus 8. And with long division, you want to focus on just the first term. I'm not looking at the 8. I'm not looking at the 3x right now. I'm looking at the first term and the first term. So x squared divided by x is an x. X squared divided by x is just x. So the x is what's going to go in the top. And then we're going to multiply. You multiply the x that you just put in the top times the x plus 8 that's out front. So x times x is x squared plus 8x. The next step is to subtract. So x squared minus x squared goes away. 3x minus 8x is a negative 5x. Bring down the negative 43. Again, you look at those first two terms. Negative 5x, look at the negative 5x and the x. So negative 5x divided by x is negative 5. So minus 5. And then we're going to multiply that negative 5 times the x plus 8, giving me negative 5x minus 40. Again, we've got to subtract. So negative 5x minus a negative 5x goes away. Negative 43 minus a negative 40 makes that plus 40, so a negative 3 is my remainder. And any remainders that we get always go over the divisor. So this will be minus 3 over x plus 8. Now, there is a lot that goes into long division. Lots of little details that you have to make sure that you're looking at. For example, all of my like terms are always in the same column. So I highlighted that one column because all of those are x's. A lot of students will make mistakes when they first start off dividing x squared by x and putting the x here, which is wrong. With long division, the order in which where you put stuff matters. Like terms are all in the same column. If you look at that last column, those are all constants. Your x squares always end up in the same column. So that's long division. The answer to number 3 is your x minus 5 minus 3 over x plus 8. Now, synthetic division is brand new to you. You've never seen this before. I love synthetic division. I will choose to do synthetic over long division all day, every day. It's a little tough to get used to at first, so bear with me. The first step in this is to take your divisor, which is the x plus 8, set it equal to 0, and get x equal. So I'm going to subtract the 8, and I get x equals negative 8. Now we're going to use that negative 8. I'm going to put it out front and put it in a little box. So then I need to address this x squared plus 3x minus 43. We're going to get rid of the variables. So what I love about synthetic division is the variables are going to go away. We're only going to use the coefficients. So on the x squared term, there's a 1. On the x term, there's a 3. And then my constant goes last. And then we're going to leave a little space, and we're going to draw a line. And I'm going to put another little box here, and I'll explain it in just a second. The first term in synthetic division always comes down below the line. This bottom row of numbers that we're about to fill in is where you're going to find your solution. Bear with me. If you can multiply and you can add, then you can do synthetic division. At this point, we want to take the negative 8 that's in the box, and we want to multiply it by the number on the bottom row. Negative 8 times 1 is negative 8, and that's going to go above the line. And then from here, we're going to add. 3 plus negative 8 is a negative 5. And then we're going to repeat that process. We're going to take the negative 8 times the negative 5 and get a positive 40. That's going to go above the line. Negative 43 plus 40 is negative 3. Now, again, I just said a second ago, the bottom row is our answer. You just have to interpret it. And I want you to think back to the very first term. If I take x squared and I divide out an x, I'm going to get an x. So if you take that beginning and decrease its exponent by 1, your answer at the bottom starts out with an x. So your final answer is x minus 5 minus 3 over x plus 8. Now, both of these are the same problem. You'll notice that the answers are identical, but the method that I used to get that is a little different, but the same answer. Let's look at more synthetic division. The directions here say to use synthetic division to divide the polynomials below. And I have a little additional piece of information here. Your dividend and your divisor must be in standard form. Must be in standard. So 2n squared minus 16n plus 19 is being divided by n minus 7. So I've got my dividend divided by my divisor. We're going to take our divisor, which is n minus 7, set it equal to 0, add the 7, and we get n equals 7. Again, the 7 gets used. We're going to put it in a little box. We're going to get rid of our variables, make sure it's in standard, and then we just need those coefficients. I need the 2, the negative 16, and the 19. Leave a little space, draw a line. And again, this box, the reason why I add that box is because that's where your remainder will always show up. You always, again, bring that first term down and then start multiplying. 7 times 2 is 14. Always add. Negative 16 plus 14 is negative 2. Multiply again. 7 times negative 2 is negative 14. And then add 19 plus negative 14 is going to be a positive 5. It started out with a 2 as the exponent, so we're going to decrease that by 1, and my final answer is 2n minus 2. That's a positive 5, but it is the remainder, so it goes over the n minus 7. Looking at, I'm going to jump to number 7. On number 7, it says missing powers in the dividend. So I've got k cubed minus 17k plus 32 divided by k plus 5. Again, k plus 5, set that equal to 0, subtract to get your number that goes in the box. Now, what I would like to point out is it starts with a k to the 3rd power. So when I'm doing synthetic or even long division, if there is a missing term, you have to hold that spot with a 0. So the k squared is missing. So I'm going to put a 0 k squared here, right? So 1 k cubed, 0 k squared, negative 17k, and then my 32. Bring that first term down. Negative 5 times 1 is negative 5. 0 plus negative 5 is still negative 5. Negative 5 times negative 5 is 25. Negative 17 plus 25 is going to be 8. Negative 5 times 8 is a negative 40. And then 32 plus negative 40 is going to be a negative 8. And again, the highest power in my dividend is a 3. So we're going to decrease that by 1 because, again, you just divided out a k. So my answer starts with a k squared. They decrease as you go, so that's going to be a k. The number right next to the left of your remainder box is always a constant. And again, the number that's in that box is always the remainder. So my answer is k squared minus 5k plus 8 minus 8 over that k plus 5. Let's look at number 9. Looking at number 9, I have m to the 3rd minus 12m squared plus 33m divided by m minus 5. So same thing, I'm going to start it the same way. Take your divisor, set it equal to 0, and then get the variable by itself. That's the number that goes in the box. Now, when you look at this one, m to the 3rd, and then I got m squared, I got an m. What's missing? The constant is missing. So this plus 0 out on the end needs to be there. Even if it's just a constant, you need to make sure everything is represented when you set up your synthetic division. Bring down the first number and multiply, add. Multiply, add. Multiply, add. Now, I went through that pretty quick. You may not be able to do it as quickly as I can. That's okay. But you are just multiplying and adding. The largest exponent is a 3. Decrease that by 1, again, because you just divided cubed by the first power. So when you subtract those exponents, you get the m squared. So m squared minus 7m minus 2 minus 10 over m minus 5 is my solution for number 9. Now, the one thing I haven't not mentioned up to this point is that your leading coefficient on your divisor should be a 1. And on every single one of these that we've done so far, the leading coefficient is a 1. But on example number 10, that's not the case. I have a 3x minus 7. So let me bring this down just a little bit further so you can see what I've got written here. You will divide everything by the leading coefficient to start and multiply the remainder by the leading coefficient to end. So let's look at what that might look like. On number 10, 3x cubed minus 28x squared plus 76x minus 67. Everything's there, have no missing terms. But then I'm dividing by this 3x minus 7. So we're going to divide everything in here by 3. And I'm going to warn you up front, you are going to have fractions as you go through this process. So I'm going to have x cubed minus 28 divided by 3 does not go evenly. So I'm going to leave that 28 over 3x squared plus 76 divided by 3. Again, does not go evenly. So I'm just going to leave it 76 over 3x. 67 does not divide evenly by 3. So leaving it negative 67 over 3. And that's divided by x minus 7/3. So take your x minus 7/3, set it equal to 0, add your 7/3, and we get x equals 7/3. And that's what's going to go into the little box out front. And then I'll use those leading coefficients. 1, negative 28/3, 76/3, and negative 67/3. And here we go, and I'm about out of space. This is about to get ugly. We've got a 1 to start. 7/3 times 1 is 7/3. Negative 28/3 plus 7/3 is going to be negative 21/3, or negative 7. 7/3 times negative 7 will be negative 49/3. And I'm sorry, I'm having to go to the side here. And then you're going to take your 76/3 plus negative 49/3. And you should get 27/3, which is 9. Multiply again. 7/3 times 9 is positive 63/3. Negative 67/3 plus 63/3 is negative 4/3. Now, here's why we have to multiply by the number that we originally divided by. Your remainder is a fraction. And let's look at what happens here. So if I write my answer, I've got x squared minus 7x plus 9. And if you were to leave it 4/3, you would have 4/3 over your, it would be x minus 7/3 technically. But you cannot have a fraction inside of a fraction. It's not allowed. So because a fraction inside of a fraction is not allowed, what you can do really quick is just take your remainder and multiply by, we divided by 3. So I'm going to take negative 4/3 times 3. The 3's go away, and we're left with negative 4. So your remainder is negative 4, and it goes over the original 3x minus 7, the original divisor. Now let's do that again. On number 12, let me look at number 12. Number 12 is all kinds of messed up. It is not in standard form. It looks like I have, actually, you know what? Let me back up. Let me do number 11. The reason why I want to do number 11 is because number 11 is also all kinds of messed up. It's not in the correct order, and I see a missing term. So first thing we got to do is put it in order. So it's going to be 7n cubed plus 2n squared. And if it's okay with you, there's no x. I'm going to go ahead and put a 0x here, minus 10. So I'm holding that spot, and that's being divided by the 7n plus 2. Everything's going to get divided by the 7. So 7n cubed divided by 7 is just n cubed. 2 divided by 7 is going to stay 2/7 n squared. 0 divided by 7 is still 0. 10 divided by 7 is 10/7. And that's being divided by 7n divided by 7 is n, plus 2 divided by 7 is 2/7. Again, take your n plus 2/7, set it equal to 0, and get your n by itself. So negative 2/7 goes in the box. I've got my 1, the 2/7, the 0, negative 10 sevenths. And then we are going to multiply, add. So 1 comes down. Negative 2 sevenths times 1 is negative 2 sevenths. Add, and you get 0. Negative 2 sevenths times 0 is 0. 0 plus 0 is 0. Negative 2 sevenths times 0 is still 0. And we get negative 10 sevenths as our remainder. So the answer here is a little tricky. When I decrease this exponent by 1, I get an n squared. But notice that my linear term and my constant term are both zeros. So we don't write those as part of our answer. And don't forget, we divided in the beginning by 7, so we're going to multiply by 7 to get our actual remainder, which is negative 10. So n squared minus 10 over my 7n plus 2. So there's your answer. And those are your notes for Chapter 8, Lesson number 2 on dividing polynomials.